look at, we're going to start off with problems. This is 9, 11, and 12. So like on number 9, one thing for this next test you should be thinking is, did they give me an equation? It says the equation of the line, this line is what? They gave me 4 different equations. I'm just going to type all 4 of them in there. X equals 0. Is that what the line looks like? Because this line is not on the y-axis. So let me try, oh sorry, let me unfreeze it. Y equals 0. You should be seeing your own decimals. You shouldn't have to see mine. You should be listening. You should have already put it in there. Y equals 0. Now that's the blue line that is horizontal. That's not what I need. I need it to be a vertical line that passes through 3. So let's see, x equals 3. Now I'm looking for my green line. Okay, here is a vertical line, and yes, it passes through the 3. So this answer, you should go ahead and circle x equals 3. I'm not circling it for you. I need to make sure you're paying attention. The slope of the line. Now, there's a poster in your class, okay? There should be a poster in your class that tells you 0. Oh, remember we talked about the z? Which one actually has a z in it? Horizontal or vertical? Which type of horizontal has a z? All horizontal lines have 0 slope. Undefined, that's for your vertical line, okay? If you thought the slope was 3 or -1/3, it's going to be one of the diagonal type lines. These lines are different. All vertical lines should have a undefined slope, okay? The slope is not the x. We keep talking about it. The slope is the m that is next to the x. Okay, moving on. Which of the following functions represents a line which is parallel to the line contained in the table? Well, first of all, parallel lines, you need to know what that means. What does parallel line mean? If you don't know that, it's the same what though? The same what? If you don't know, look at the poster. Please pay attention here because somebody needs to take their checkpoint from yesterday. So this can help you. Parallel lines, it must be the same exact slope. A lot of you guys took the checkpoint yesterday and did very well on it. So it's been 24 hours. I hope you didn't forget. If you did, look at the poster. So the same exact slope. But what is the slope? Did it give you the slope?
No, we gotta find it.
You gotta find it. Thank you. So how do I find it?
You put the table in.
Putting the full table. I would put the whole thing, just so nobody's confused. Put the table in here. And then the next step. Anytime you need to find a slope, y'all, there's another time on the test you're going to need to find a slope besides this one. I just want to remind you how to find it. So now this pops up. All of these represent, there's so many different letters. Do you remember which one is actually the slope? What is it? Is it the r squared, huh? Right next to the m. The m is your slope. So that means this table has a slope of negative 0.5. If you miss the negative, you might miss the problem, which is the same thing as negative a half when you change it. So it said, let's go back and make sure we need parallel. Parallel means the slopes must be exactly the same. Remember, your slope is next to your x. Your slope is next to your x, as long as the y is by itself. So which one actually has a slope that is the same? Thank you. So please circle the full answer, whatever answer it should be. And we're moving on. Read each statement and determine if the statement is always true, sometimes true, or never true. Two lines with positive slopes are, this should be sometimes parallel. I know we didn't really talk about that, but let me give you an example. Let's say we have a slope of, let's just say the slope is 4x over here, and this slope is 1 over 4x. Just because they're both positive doesn't mean they're parallel. They have to be the same positive and the same number. All right, so be careful because these two would be neither. Okay, that's just an example. Horizontal lines have 0 slopes. Always, sometimes, or never. Look at your poster. You must have not looked at the poster because this one should be always. Look at we just wrote it right here. Always. All horizontal lines all have the 0 slope. Okay? Tell your neighbor all horizontal lines have 0 slope. Thank you. A line with the slope of 9 is perpendicular to a line with the slope of -9. Does anybody remember the criteria for something to be perpendicular? What's one of the things that it needs to be perpendicular? Hello, there's a big poster behind it. Ain't no reason why y'all look at the poster. Must have what? Different signs. So do they have different signs? Does this slope and this slope have different signs? Yes. However, the second rule is must be a reciprocal, which means flip fraction. This fraction is 9/1. Did they flip it over here? No, they didn't. Never. If the slope wanted to be perpendicular, it would have had to be a -1/9. That's how you flip a 9/1. Any questions before we move on? So taking a look here, we were just talking about you need to know what type of line this is. This is a vertical line, and you will use your poster. I was just explaining that slopes for vertical lines is not a number. It's undefined because you can't really define dividing by 0. You can't divide by 0. That's how you get undefined. And the equation is always x equals, and you need to look at where the graph touches the x, at the 5. This only works for vertical lines. Same thing for horizontal lines. All the horizontal lines have a 0 slope. They don't have like a different number. They're all 0. And the equation for this one has to be what? All vertical lines are x equals. Only vertical lines are x equals. It's the y's that are y, and where does it touch? -3. Okay. Now going back to number 13. It says which equation is best represented by the graph? So they give us a graph. It touches at -3. It touches at 6. Let's look here. What are we going to do with these? Well, let's match it. Our goal is to get the equation and match it. Let's put it in here. 6x minus 3y equals -3. Uh-oh, we have a triangle. What's wrong with that?
You gotta move that's it. The stupid standard.
Thank you. It's stupid standard form, so I need to move what?
Move your 6x to...
Move my 6x to the other side of the equals. Please make sure you bring down the minus sign with this 3y. But back here, what am I going to write? Minus 6x, because we move the opposite. Next step.
You gotta divide by -3.
Ooh, thank you. Stupid pen. Divide by -3. Divide everything by -3. What I'm catching is some people are getting a little bit lazy on this step, and they're just writing whatever they think it equals and what they think it equals. If you write what you think it equals, you might not be right. Because a lot of people they need a little bit of practice with negative divide by negative. I see that. They think, oh, it's going to be negative. Well, let's see. -3 over -3 is a +1. And then I'm going to check my next one. -6 over -3 is a +2. Don't forget your x. Now we're going to see, does this match the line? I'm just going to take all that out. I'm going to put in y equals 1 plus 2x. How do I know if it matches the line? Why won't it move? Sorry. Match the intercepts. It must touch at -3. Look at your graph. It does not touch down here at -3, so I know it can't be A. So I'm going to cross A off of my list, and now I'm going to solve letter B. This one's going to take some time to go through, so next, solve B and see what you get.
Miss, I was already doing it, but is it okay if
Already working this out because I didn't want the video to be too long. -1 then that will actually be a positive 1 over 2x. Let's see what this gives us. I can already see this y-intercept don't match with the y-intercept I need. Okay, now it doesn't want to move over here. Okay, so now our equation is y equals -1 plus 1 over 2x. Once again, that y-intercept is at -1. But on my graph, the y-intercept is at -3. So you would have to keep going. We know it ain't these two. I need y'all to keep going on that one to finish it up. Number 15 is very similar to the one we just did. Look, you have a graph, and you need to make sure that it touches the y at 5, but you can't see the x-intercept. So you need to find another perfect point that's on the graph, okay? That would be my idea, would to be like, does anybody see a perfect point we could use? Remind you of perfect points. Like this is not a perfect point. I know the x is 6, but the y I can't tell. Here's a perfect point. That would be 8, 3. I mean, there's lots of perfect points. I see one here. I see one here. So you can use any of those perfect points. Oh, look, there's already some that are ready. Which ones are ready for Desmos? As long as the y is by itself, it's ready. It's ready. I would check these before I started solving these. Oh, no, here's another one that's ready. Anybody find answers for that one yet? No? All right, I'm going to go ahead and, if you're watching from home, pause the video and see if you can find the answer. Make it a little faster, but you know, when people don't do their jobs, come on now, I assigned. Anyways, I'm going to shut up. Y equals -1 over 4, parentheses, x, too late now I'm checking it myself, plus 4. So we know it's already e because we already checked that with somebody. And now it looks like it could, as long as it touches the y at 5, and then we have 8. Yep, there we go. That's perfect. So D is the next answer. There's one more answer. H is the last answer. And H is kind of scary because well, not scary, but we have to work it out. So for H, you would have had to once again work out the standard form equation. And if you notice, it looks like, please be quiet. Once you work it out, you are going to get that same, what's 20 divided by 4? Of 5. And -1 over 4, that's what we needed. So yes, thank you. I'm glad some other people were working on that one. All right, so I'm going to end this video.